Good morning to all of you. Am I audible to you? Screen is, I think I have to share now. Okay, audio is okay, then screen is visible. So then we will start the class. So now we are discussing the linear block codes, and please keep your mind today on the slides only. This is a Reed Muller codes we are going to discuss. It's a little bit complex compared to the linear block codes what we have done so far. Reed Muller codes. Muller, 1924 to 2008, he is a mathematician, and another person is a Reed, who was there 1923 to 2012. He was also a mathematician and also an engineer. These two people contributed for this code. Reed Muller codes are error correcting codes discovered by Muller in 1954, but decoding was developed by a Reed. These are used in the wireless communication applications as well as in deep space communications. Now, the Reed Muller codes for each positive integer m and each integer r is in between 0 to m, there is a rth order Reed Muller code. We write down rm in the bracket r comma m with the following parameters. All of you know some of the parameters we have discussed in linear block code. Similarly, we are talking about a Reed Muller code. Code length n equal to 2 raised to m. Dimension is given by k of r comma m equal to 1 plus m choose 1, m choose 2 up to m choose r. D minimum, which you have discussed there also, here it is a 2 raised to m minus r. What is the meaning of this, sir? M choose 1, m choose 2, m choose 3, etc. What you have written? This is nothing but m factorial divided by m minus I factorial into I factorial. So it is a binomial coefficient. I want you people to copy down this particular slide and try to understand. I will wait. Let us take m equal to 5 and r equal to 2. N equal to 2 raised to m, n will become 2 raised to 5. So it will become 32. Dimension, just I will fill the value of these things. M equal to 5 I am filling, r equal to 2, therefore up to 2 I will take. I will not go 3, 4, etc. because r is 2. Now, copy down this and write down the next step. 5 factorial divided by 5 minus 1 factorial, like that you just write down. I will give you 1 minute. Write down 1 plus 5 factorial divided by 5 minus 1 factorial into 1 factorial plus 5 factorial divided by 5 minus 2 factorial into 2 factorial. I want you to write the answer in the chat box. Very good. Everybody is getting the same answer, 16. Even I too got a result 16. A minimum distance, d minimum equal to 2 raised to m minus r equal to 2 raised to 5 minus 2, will get a 8. Now, let us go to the next. Hope all of you have the same answers. No need to wait for the copying. Now, take a m equal to 4 and r equal to 2. I want you people to considering m equal to 4, you do it. So this I have typed 5 only, but you take it as a 4 and do it. 4 factorial divided by 1 minus 4 factorial, 4 minus 1 factorial, 1 factorial. What you have done for 5, do it for 4 and write your answer in the chat box. Very good. Everybody is telling 11, sir. Answer is correct. Just anyway, I will show you the answer. You people got the same answer. Now 1 plus 4 plus 6, I got a 11. So these n equal to 16 value we are going to make use in our discussion. So remember, r equal to 2 we are going to use in our discussion. Minimum distance d minimum equal to 2 raised to m minus r equal to 2 raised to 4 minus 2 equal to 2. So 2 raised to 2 is nothing but 4. This is a These are the things what we are going to use in our discussion, because we have to take one example to discuss the encoding procedure, decoding procedure of a Reed Muller code. So these are the things we are going to consider as an example for a discussion. Hope all of you have copied, because your answers are also same. Now, just recall what all we have discussed for the linear block codes. C is equal to D into G. To get the C, we need a G. In this also, we are going to talk about only the G now. If I get a G, sir, next, the same procedure, encoding C equal to D into G we can do, but we concentrate on G only in this particular subtopic. Then after that, we straight away go to the decoding procedure, how to do the decoding. But it is a little complex compared to whatever we have discussed so far. Hence, I told you people to go through, read it, try, and attend the class without fail. So let me go to the next. Now let us discuss the rows of the G matrix. The way how we have discussed for a earlier linear block code. Now for this we are going to discuss. First row, how many zeros, ones, what combination, what is the pattern you have to take. Similarly for second row, third row, how we have to do that only we are going to discuss now onwards. Now how we are going to construct, we are defining a 2 raised to m tuple. Let us call it as a vi, v1, v2, v3, v4 like that. I goes from 1 to m and I is in between 1 to m. Let vi be the 2 raised to m tuple over Galois field of 2. Galois field of 2, 0, 1 we take for the following form. What we do, for example, vi equal to few zeros, few 1, few 0, few 1, few 0, few 1, we continue. And this I depends on this I, these how many zeros I have to write, how many ones I have to write, we decide. For example, I is a 3. Then how many zeros I have to write? 2 raised to 3 minus 1. Those many zeros I have to write. So which consists of 2 raised to m minus I plus 1, alternative all zeros and all ones. 2 raised to I minus 1 will be there. So just I want you people to copy down this. Even if you do not understand this also, no problem, because we are going to discuss with a numerical example after this. Vi equal to zeros followed by 1, zeros like that. How many zeros? It is 2 raised to I minus 1. For example, I equal to 1, I equal to 2, I equal to 3, I equal to 4. How many zeros and how many ones I have to do it? Let us take v1 equal to how many zeros and ones. v2 equal to, I want you people to just think and type your answer in the chat box. v1 bole to how many zeros followed by how many ones. Like that I had to do it. It is given here. It is a 2 raised to I minus 1. I is 1, I is 2, I is 3, I is 4. Fill the I value 2 raised to, then you will get a number. That number you tell, sir, these many zeros, these many ones. For v1 or v2 or v3 or v4. Take a minute. Total 16, because I told in the beginning, total 16 bits we take. M equal to 4, therefore v1, v2, v3, v4. v1 1011, this I have to repeat, correct. I want all to type v1 to v4. Okay. So hope all of you have written V1, V2, V3, V4. compare your answer. All of you know the Boolean product. Bit to bit we are multiplying, v1 into v2, bitwise we multiply. All of you know 1 into 1 is equal to 1, meaning 0 into 1, 1 into 0 or 0 into 0, all will be 0. Now multiply v1 into v2, write your answer in the chat box. Priyanka has given the answer. Total 16 bits should be there. Nisarga has given the answer. Priyanka, just see the number of bits, how many I have. I think 12 bits. And Nisarga is having, I think, 16 bits. All the 4 students have given the v1 into v2 multiplication. So good. You and I too got the same answer. Let us go to the next. How to construct the RM code? For that only we are discussing a row of rows of a G matrix. So let us consider V0 denote all ones. Just copy down V0 equal to all ones, and we have V1, V2, V3, V4, and remaining rows of a generator matrix we will discuss. Take a V0 equal to all 1. Let us go to the numerical example discussion. We will continue that instead of discussing these. Reed Muller code. Rth order Reed Muller code. We represent like this: R, M of a length 2 raised to m is generated by the following set of independent vectors. Generator matrix R, M equal to, we write V0, V1, V2 up to Vm. Then V1, V2, V1, V3, V1, V4, V1, like that we continue up to Vm minus 1 into Vm. Now in our case only m is 2. If I take a 5, 6, 7, it depends. Like that I have to multiply up to the product of degree r. There are k of r, m equal to 1 plus m choose 1, m choose 2. This we have already discussed. If vectors in the generator matrix are arranged as a row of a matrix, then the matrix is a generator matrix. Whatever I discussed, all these things, no? V0, V1, V2, and V1, V2, V1, V3, etc. If I arrange them as rows, so that will become a generator matrix for a Reed Muller code. I want you people to copy down from the slide, then we will go to the matrix. Once we get generator matrix, and getting a code is not a problem, that we will not discuss. Then straight away after getting a generator matrix, we will go for a decoding procedure. Let us go to the next. This is a V0, V1, V2. I'll give 1 minute. I want you people to write V1, V2, V1, V3, V1, V4, V2, V3, V2, V4, V3, V4. Take a minute. First, if you write down all these things, followed by these things. And V1, V2 is already with you. The remaining 4 you have to write. Take a 2 minutes and try to complete it. Just multiply V1 into V4, write down here. V2 into V3 you multiply, write down here. V2 into V4 you multiply, write down. I will show you the answer. You can compare it. This is what I got. You can compare. If it is same, you can type same in the chat box. Else we will discuss. Very good. Okay, most of them they are getting a same. Very good. Let me go to the next. Now we got this degree of 1. We have a V1, V2, V3, V4. And V1, V2, V3, V1, V3. This is a degree 2. Why we say degree? We have taken 2. So if I take V1, V2 into V3, it will become degree 3. Now we have taken degree 2 in this example. So write down 11 cross 16. V1 to V4 we have written the remaining degree 2. And it will become 11 cross 16 generator matrix G equal to. Once if we have a G, encoding can be done. So instead of discussing the encoding part, we will go to the discussion on the decoding, because always decoding is complex in any decoders. Any coding system you take, decoding will be a little complex compared to the encoding. Just write down beside that r equal to 2, m equal to 4, it's 16, 11 with a minimum distance of 4. Now decoding of a Reed Muller code. Again we are taking the same example, whatever the values you have taken, n equal to 16 you have taken, m equal to 4 and r equal to 2, all these things you have written so far. So this is, take a heading, a decoding of a Reed Muller code. This is the same thing, and if you want you can rewrite, or we take this as a G and we will continue the discussion. For decoding we use a G matrix. So let us consider the same G matrix what all we have discussed so far. We are taking an example how to decode. Say I have 11 bits. Those bits are represented by A0, A4, A3, A24, A14 like that. The code word is given by a linear combination of rows of G, the way how you have taken for a LBC. Say I am representing this B0, B1 up to B15, 16 bits what I have, and these are given by encoding procedure A0 into V0 plus A4 into V4. This is just C equal to D into G hidden. So let us consider how this 16 bit in my hand, how I got 16 bit using the same procedure. This I have done it, A12 into V1 into V2. So just copy down this. We'll have how to decode A0, A4, A3, A12 one by one, how to decode, that we are going to discuss. We are going to decode bit by bit, a lengthy procedure. Very good. It is like a C into equal to D into G. A generator matrix we have. There only we have these rows. First I have E0, V1. So then these things I have. Now it is a linear combination. That's all. Let us go to the next. Now we can see that first 4 components of each generator vector and subsequent 3 groups of 4 consecutive components is 0 except for the vector v1 v2. This sentence only we are going to discuss in the next slide, and these equations how we are going to get. So let me go to the next slide, and before that you remember one line. RM Reed Muller code uses the majority logic decision rule for the decoding. This one line you have to remember. These things again we are going to discuss in the next slide. Just you go through, I'll give you 30 seconds for you, but discussion we will do in the next slide. Consider group of 4. So these 4s, hope it is visible to you now. Add any 4 bits in each group, row wise, result will be 0 most of the time. Search any row where result is not equal to 0. Start from V0 up to V3, V4 you try. Then let me know the answer. For example, if you add these 4, result will become 0. If you add these 4, result will become 0. If you add these 4, result will become 0. For example, if you add these 4, result will become 0. If you add these 4, it will become 0. If you add these 4, result will become 0. Everywhere is it true or somewhere it is not true? Just take. Very good. I think Rashmi has told within a few seconds. Sir, V1 and V2 if you check, I think it's not 0. So, very good answer. The same thing. See, when I add these, everywhere it is a 0. So, 4 ones it is a 0. And for example, 4 0. Again 0 1 0 1 0. All 0 it is 0. And all ones 0. Yeah, it is true. But in case of V1, V2, you take any row, it is not 0. Observe this. If you add all 4, 1. If you add all these 4, 1. If you add these 4, it 1. If you add these 4, again it is a 1. Only V1, V2 is not 0. How to make use of this particular thing? That we are going to discuss now. Just copy down these 2 information. Actually what I did, I am adding these 4. 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 These only we are writing equations. Say for example A1 equal to these B0, B1, B2, B3. Then A2 equal to this addition. Like that I am doing the equation. I'll be showing you the next slide. Already previous slide I shown that. Again I am going to show you in the next slide. Copy down now. So code word is given by B0 to B15 and you have taken this equation already. I am concentrating only on V1 into V2 where multiplication is 1, remaining all are 0. When we add up first 4 elements, the contribution from all other will be 0. This we have discussed just now I have shown. Except A12. So A12 is non-zero. So we will get a contribution from A12 by considering that equation. And I want you people to copy down 1 or 2 lines from this. I'll give 1 minute. Then those equations. Try to understand, when we add up the first 4 elements, the contribution from all other will be 0. We have discussed just now. Only A12, which is not 0. So we'll get a contribution from A12. Very good. Most of them they are completed. Thank you. Now, we can write an equation A12 equal to B0, B1, B2, B3 and A12 equal to B4, B5, B6, B7. So how we are writing? We are assuming this column is a B0, this column is a B1, this column is a B2, this column is a B3. So 4 at a time we are adding. So A12 I will get adding this and A12 I will get adding this, A12 I will get adding this, A12 I will get adding these 4. That only I am doing here. So these are the equations I want you people to copy down. 4 bits I will take consecutively. That will represent A12. Copy down these equations. Good. Most of them they have copied now. A12 equal to. This is the way how I told just now. And above are 4 independent views of about A12. So if I get this as a 1, this as a 1, this was a 1, this if I get 0, sir, what to do? Go for a majority logic decision. Means if you have these 3 as a 1, take it as a 1. Okay, whichever is having highest, that you have to choose. Sir, if all 3 are zeros, sir, if we are equal, 2 or 0, 2 or 1, we can take randomly. Okay, take a 1 line. I'll wait for you. Copy. Let us consider received as a R instead of B0, B1. What I am using R0, R1. R stands for received. R0 to R15 for decoding. A12 we form the following sums. A1 equal to R0, R1, R2, R3. Instead of B, I am taking a received. And A4 equal to R12, R13, R14 and R15. Sum AR. I mean to say A1, A2, AR called or checksum and estimation of A12. A12 I will get a 4 options. Okay, A1, A2, A3, A4 for a A12. So just these equations are with you. Instead of B0, B1, I am considering received. Therefore, I am replacing that as a R0, R1, R2. This A12 and this A12 same. It is a lower case E I have typed, but it has become capital. Now I have a 4 option for A12. Similarly, A13, A23, A14, A24, etc. I have to do it. So choose a combination such that only, for example, A13 should become 1. A13 is nothing but V1, V3 should become 1, remaining should become 0. The way how we have done beginning. When I consider only these 4, these 4, these 4, these 4, only for that row, V1, V2 was 1, remaining were 0. Like that I can choose particular columns. To make a particular A13 is 1, remaining all are zeros. Take a few seconds and glance. Observe this you can do it in your rooms many times. See, if I take a B0, B1, B5, B6 if I add, answer will be 1 for say V1, V3. But if you add the same columns for other V0, V4, V3, it will become 0. So please try to understand B0, B1, B5, B6 if I add, it will become 1 for V1, V3. If I add for remaining, here and there try randomly, it will become the 0. Only for this row, it will become a 1. So I can write an equation using these columns. I choose a combination such that only A13 should be 1, other should be 0. These will contribute as a 0, even including this. Only this row will become a 1. So I want you people to note down that arrow mark for A13 using a pencil, keep this matrix, the big matrix in your notebook neatly written. Do the revision after the class so that it will become easy for you to understand. I have to consider those rows and I have to write the equation. Equal to B0 plus, can you type in the chat box what's the equation? Try. So B0 is mentioned, B1 is mentioned, then I have to add B5, I have to add B6. This equation becomes, see, B0 plus B1 plus B4 plus B5. And next, similarly, I can add this with this with this, all four. I'll get a B2, B3 plus B6 plus B7. I think Nisarga has typed. Not B5, B6, it is okay. This may not match 100% with this, but you count B0, B1, B2, B3, B4, B5, B6, B7. Like that you count it and write down. These are the equation what I am going to write for A13. Okay, so copy it. How I will come to know? You have to spend a little time and you have to search it. This is the way how we have to do it. It is already given in the book. We are going little fast. But when you try, you will get these things. And next time I am adding these two and these two. Next time I will add these two and these two. I will add these two and these two. Only this row only I have to consider. Remaining will become 0. So that I could be able to decode A1. Very good. Nisarga has typed the equation. Correct. This is the A13. Now, let me go to the next. Hope all of you understood this. Similarly, A23. And these are the equations. So for that, similarly for other also, I have to see the matrix and I have to write down. So these are the equations for your reference. And for A23, A1 equal to R0, R2, R4, R6. A2 equal to these 4 I will get. And among these 4, majority whichever is there, that I will take it as a result. And this is for A23, what I got. So now we have taken for a A23. Similarly, we can write for others also. A14, A14, A24. These also you can note down fast. The matrix is such that even if you write 2, remaining 2 will be easy. By observing this, you can observe here first one, then alternative R1 you are taking, then R8. Here you can observe that the gap will be same. Okay. Similarly, A1, A2, A3, A4, A24, A34, all these things you are doing it. Combination should be such that it should give a information about only one particular transmitted bit, not other bits. That is the way how we are writing. Like this, let us consider we have decoded all A12, A13, all these we have decoded. Then, after decoding all this, we rewrite again R dash instead of R. So for your written R. Now I am writing R dash equal to R minus all these contributions I will deduct. R minus this A34, A24, A14, A. Those who are not understanding this, I will show you the another slide. From that, I am sure you will understand. Now we know that this is a complete B0 to B15, 16 bits were there. This was the total equation. Now we have done R minus this much. So all these things I have to subtracting. So remaining is what? A0 V0 plus A4 V4, A3 V3, A2 V2, A1 V1. Because meaning I have subtracted. So this is very important. I want you people to understand this. Now only you are supposed to copy this equal to. For your reference, I am showing all these things. Again, I am showing you. Those who are having still difficulty to understand, I made another slide. This is a complete. But I am subtracting this. Remaining is only this. Now I have to decode A0, A4, A3, A2, A1. So those who are getting difficulty to understand, this much I have subtracted from R. R is nothing but this total. So after subtracting this, only this will remain. It's the same. Let us go to the next. Now we decoded the terms R. Now we have decoded the R minus 1 terms. To decode the first order, follow the same procedure. Now A khatam ho gaya hamara. Now I have to discuss only about V0, V1, V2, V3, V4. These things we did it. Again you have to go to the G matrix. Again look at this. Again follow the same procedure. Again you have to write the equation. Procedure will remain same. Whatever you have done for this. Got it? Just copy down. In this example R is 2. Okay. Second one you have done. R we have done means second one you have done V1, V2, V1 in this second order. Now remaining is R minus 1 means first order. Only we are taking a R is 2. If you take 3, 4, 5, 9, it will be still more complex. Now only look at a first order. So A1, again you have to write the equation. Now for a A1, B0 plus B1, B0 plus B1 and B2 plus B3. If I add first, second, third, fourth, fifth, sixth like that, for this it will be 1. For remaining it will become a 0. Okay, you can try, but directly equation is given because it is difficult to discuss all combinations. So just copy down this and try to understand. All of you know how to write the equation. So for other combinations, for other rows it should be 0. Only for this particular it should be 1. And if you copy a one equation and if you mark here only like a line, even you people can write down all these things easily. Now we are done for a A1. You will get 8 views for A1. 8 answers you will get. Again, which one to select, sir? Majority logic decoding, whichever is majority that you have to follow. Same procedure can be done for A2, A3, A4. Say let us consider you have decoded A1, A2, A3, A4. Then what to do? That we are going to discuss next. Take a one line from this. Similarly, you have to do it for A2, A3, A4. I need a separate 1 hour just to discuss the Reed Muller code because it takes a time. Now remove the effect of A1, A2, A3, A4 from R dash. R dash we have written. Now after modifying, I'll write that as a R raised to 2. R double dash. There these I had to minus. Earlier second order I have subtracted. Now first order I had to subtract. Now left with a A0, V0. So A0, V0, I'll get many answers. In that again I have to go for majority logic. So this will be the almost completion of the Reed Muller code. Copy down this and one more slide is there. We'll discuss that. So this gives a 16 independent determination of A0. Set A0 the value taken by the majority. So 16 values I will get which one I have to take, whichever is majority, 0 is there or 1 that I have to select. Decoding is referred to as majority logic decoding because we take a majority. This completes the decoding and it consists of 3 steps of decoding. It is also called as 3-step majority logic decoding. So this completes your Reed Muller decoding. Copy down. So now we'll conclude the class. Take care, be safe, have a good day. I'll be here for another few minutes. Anybody is having to discuss, you can discuss. And coming Saturday, let me know your progress on the given homework.